Hello everyone, it's Chris from CLS here. I'm going to do a repair today on a D22 blower motor fan assembly and the resistor pack that comes with it. Now the symptoms are, for my particular D22, which is it's a 2009 model Nissan Navara, what I found was it stopped working basically on the 1, 2 and 3 fan speeds, and it only kept working on fan speed number 4. Now, that's okay if that's all you want to do, you just have the fan on full all the time, but that's a bit of a pain to me. So I like the fan speeds 1 and 2. Quite often I use them, and it helps demist and defog the car as well inside in rainy weather. So what I did is I found a manual, which is an online manual, and I downloaded the whole online manual, and then from that I was able to look at the components within the car and pull them out, and I found this particular resistor pack. So there's your circuit diagram for what we're going to be dealing with today, and here's the component that failed. Now this is the blower motor resistor, and they sell them for around $90 at Nissan here in Australia. Now that's a little bit expensive, I suppose, for what is a redundant part. Now it lasted 10 years and 9 years. My ute's 9 years old, so it lasted around 9-10 years. And what you can see here is right there, if we zoom that in a little bit, there, right there, there's actually a fusible link. I suspect it's around 10 amps, something like that, and then it blows. These tracks, they all look good here, but somewhere in here, just there, it did actually burn out, and I soldered over it. So the main track coming in was burnt, and the actual the lugs, the terminals, they were all brown as well. So they had, over time, started to, let's see if I can get it even closer. Anyway, I ended up going in with a bit of sandpaper and trying to cleaning them up when I was diagnosing this. But it ended up that this resistor pack, look, it's mounted on plastic, and it's got some sort of, I can feel it's quite cool in there, so it must have an aluminium heat sink on the back of here, which is just the size of this board, which is not that big. And then what ends up happening is this gets too hot. Now this lives up inside, just next to the blower motor. I've pulled the blower motor out. Here's one, I've got two of them actually. I bought one from a wrecker because I wanted to experiment with it. Now you see this one doesn't really, it spins, but it sort of seized. It doesn't spin freely and keep going. It's actually a DC motor inside. And what's interesting about them is when you pull them out of here, and you pull this little tube off, this here is supposed to be, it gets rid of, I suppose, junk out of the system and the water that's in there. But that connects into the actual motor. You see there how it's got leaves inside this one? So I'll do another video and I'll pull these motors apart because I've already done one and I know what's inside them now. So the motor, DC motor, is actually sitting inside of here, and this cup here, this cone, conceals part of it. So when you pull all this apart and you look at the motor, the brushes themselves of the motor, they're the carbon brushes, and just like anything you see in a power tool or anything else, those brushes start to wear, and all the dust and crud that ends up inside the motor ends up inside it. And the bearings, top and bottom bearing, the two side bearings, they're just phosphor bronze bearings sitting on a shaft, and they get caked with the stuff, and it ends up putting too much pressure on this and creating resistance. And the higher the resistance goes, the harder it is for this motor to turn, the more current it sucks. And when it starts to draw current, it goes in, and this is the inline fuse. See that one there? That is the component fuse that's sitting on the side of here. Okay. So what I did, because I couldn't find any information about the actual values, the resistance values that they're using, and I thought I'd make something that's a little bit more robust and I wouldn't have to go through this process again. So I went to JCar. Look, these components are 50 cents each. These are very cheap. This is a 10 watt 1 ohm resistor, as you can see. It's a ceramic type. These do get hot if you just stick them in there like that. So what I've done is I've actually experimented with these across the terminals here. So you've got position 1, 2, 3, and 4 on the blower motor fan controls inside your air conditioning controls. And then if you look at, mine was working on number 4, it's because it's straight through. It gets power down through the main fuse packs, which is underneath your dashboard, then through the motor itself. You can see there's the motor, blower motor, and it comes through, then the white lead comes over here, and it comes straight through down into the switch on position 4 when it flicks over, and it goes down to ground, which is fine. And that's why you're getting full speed working, because it bypasses this resistor pack. The resistor pack takes off the power, positive through a white lead, and it comes down through a fuse, which is on site on the actual resistor pack itself, which is that one. Then it goes through a resistor, the first resistor, and then down to see position 3 there. And then subsequently position 2 comes up through one resistor, then through a second resistor, then out. And same thing with resistor position number 1. Goes up through a different resistor pack, and then up through the main one. So this main one's been used all the time. This main resistor, it's been used for both all positions from 3, 2 and 1, and they're just adding their values of these other resistances on top of that resistor, which basically limits the current. Yeah, but they get hot. So this pack, if you look at it, it's mounted on some sort of aluminium surface in here. I can feel it's quite cool, and it's distributing the air across this, and this is mounted up inside the air box, so it's getting air. Now that's okay when it's cool and you're running air conditioning on cold, but when you run it on heat, this bloody thing gets hot. So it's got no way to really cool this down. It's getting fresh air inside the heater box, and then it's pushing that through the circuit down through the heater core and out through your vents. So look, the design's okay. It's a little bit, it's made to be redundant, and this is made to be redundant part, hence why they put the fuse on here. Now what I did is I took this particular motor and I put an ohm meter on it across the terminals, and it measures around 1.5 ohms, okay, roughly, in the stationary position. I mean, when you move it, it's going from stator to stator inside, and it's changing. But so you know that the winding's working and the motor was working. I put some DC voltage across at 12 volts. It draws somewhere, when it's running, when it's actually spinning, around 6 amps. It actually draws quite a bit of current, and maybe it's because this particular bearing is gone, so I'll check it later and I'll let you know. But when you put a little bit of load on it, and you've got leaves and shit inside the air conditioning system, it puts a bit of resistance on this, and it can draw up to 10 amps. And at 10 amps, the 15 amp fuse isn't maxed out here, but certainly the little fuse on here is, is around 10 amps, so it blows. Now I noticed on my main circuit, the fuse circuits, my main fuses here wasn't 15 and 15, mine were actually a 10 amp fuse, okay? So my main fuse didn't blow, but this little one did. Now what I'm proposing on doing, I've actually gone to JCar and bought these components, and I've put them in line just with a bunch of alligator clips just to test them out, so I can work out what the correct resistances were to use, because the resistances here, they no longer work. When I try and put an ohm meter on this and work out what these are, these have got some sort of burnout inside, and I can't really get to it. I can't really see where it's burnt, so I'm not going to even bother. What I'm going to do, I bought these resistor packs. They're about 50 cents each, and you see here I've put, to make the values smaller, because these are 1 ohm packs and they didn't have anything smaller. They did have them in something like this, 0.5. These are 10 watters. This one's a, see that's a 5 watt, but it's 4.7 ohms, okay, and it's a little bit high. I tried a few different things. This is a 1 ohm, and I bought another 4.7. So there were a few different resistor values that I tried at first, and then I thought, you know what I'll do, I'll basically put them in parallel. So these then, every time you put a resistor in parallel with another one, it halves the two values, or it shares the value, so it halves them. That's how resistors work. So if you put the ohm meter across this, this is now 0.3. It was a 1 ohm resistor, 3 1 ohm resistors, 10 watt. This one here now is obviously half an ohm, because you've got two together, and this one is 1 ohm. And when I actually hooked them up to the system, I determined that if I put them in these positions here, the 0.3 ohm will go there in that R1, I'm going to call it. The 0.5 ohm will go in R2 position, and then the 1 ohm resistor on its own will go in R3. So when you actually switch your switches through, I've put these through and actually blow the motor at really ideal speeds. So for the motors, if you want to build this kit, I suggest you go to JCar. It cost me about 30 bucks worth of parts. I bought these components here. I bought a box I'm going to mount it in, an aluminium box with a cap on it. And I bought a heat sink, sorry. So I'm going to basically mount the resistors and have a bunch of leads coming out and plug the leads directly where the resistor pack would normally go. And then I'm going to mount this to where the slot is that this normally plugs into, because there's a slot and air blows out of this slot onto this board. But I'm going to mount this directly below it so the air can come down and direct itself over the top of these heat sinks. So I'll build that up. The main thing I wanted to get out to you was the resistor values, because a lot of people want to change the resistor values and do this sort of thing themselves. And really, the way I'm building this now, it'll be much more robust, and it won't burn out like these guys had. So I'm going to build something, and this will be the end of it. I'll give you progress photos as I go, but that's my D22 circuit diagram, which becomes useful. And enjoy making your versions of the project. I'll take a couple of photos and post them up onto the same website. Thank you. See ya.